Hello, in this video let's discuss fourth question of today's contest. A no-zero integer is a positive integer that does not contain 0 in its decimal representation. Given an integer n, count the number of pairs a, b such that a and b are no-zero integers and a plus b is equal to n. Return an integer denoting the number of such pairs. N is up to 115. For example, if n is equal to 11, these all 8 pairs are possible, but 110 or 101 are not valid because 10 has 0 in its decimal representation, not the leading zeros, but we have a 0 which is ending. So these both are not valid. So the total number of pairs is 8. Return 8. So firstly, let's say we have a number and we will fix one and we'll try to find the other one and then check the condition. But that is only possible if n is very small. But if n is up to 115, then there is no way that we can check all the numbers. So let's check how can we do this. So firstly, we want the unit digit to be processed first, because let's say we have addition of two numbers. How we will do? So we'll start from unit digit so that we can fix this and we can find, and then by carry then we can simply find the sum. So to process two decimals, obviously we'll think about the unit digit only first. So we want the unit digit. So how can we get that? So simply store the number in the string and then reverse it. So string of 0 will give the unit digit, string of 1 will give the tens digit, string of 2 will give 100 digit, and so on. So by storing the string and reversing it, we can get the unit digit first and then and so on as we traverse. So after getting this, what we should do? So now let's take some examples. So this is the reversed one. So this is the first one that we are thinking. So this is the possibility for A and this is the other possibility for B. Like other possibility means the total number minus A, which is the B. So if this is 1, then what will be B? It will be 3321, because only this digit will be affected, because this is the only length, because only this will be affected. So 4 minus 1, which is 3. So 1233 plus 1 is 1244, 1234, which is given on. So this is valid because both do not have a 0. And coming to 2, so even now 2321, and let's take 4. So if you take 4, it is 0321, which is invalid. So now let's check other also. So let's check 11. So what if A is equal to 11? If A is equal to 11, then 3221, which is 4321 minus 11. So in this way, we have many different possibilities for A based on the length, because these all are length 1, these all are length 2, these all are length 3, and so on. So for a single number, we can have many length also. So now we got that the length is important. So we have many possibilities. So let's go lengthwise. So for length 1, we can have many choices 1 to 9. For length 2, we can have many choices 10 to 99, and so on. So we should have one loop for number of digits in A, which we are considering, and we should have other loop for number of digits in B. Number of digits is simply the length. For example, if A is equal to this, length is equal to 3, which is the number of digits. So we should have two different loops, one for A and other for B. And if number is equal to 144, the string S is 441, which is reverse decoded string, which is 441. And we already discussed that we want two loops, one for the length of A and one for the length of B. So one to length and one to length, which is A and is for B. The length of string is simply 3, because we have length 3 initially. So now after fixing the both loops, when we are inside, what we will have and what we want. So when we are inside, the length is fixed for both. So for example, length is equal to A for 3 and length is equal to 2 for B. If this both is fixed, so we have the length. But what about the real numbers? So for a single length, we can have many different choices. So now the next question is, what is the exact 3-digit number for A? What is the exact 2-digit number for B? So that is what we want, because we got length fixed. So now let's say we are at index I. So if we are at index I, so I is 0 based indexing, because this is only the length, because this is only the digits, but these digits are for width. for which index in the given string? Because we have to traverse the both loops for 0, we have to traverse both loops for 1, for 2 and so on. Because we will ultimately want the total number of ways for the string. So initially when we are 0, we will use both loops and we'll get the number of ways, and we are at index 1, we will use both loops and then we'll find the answer. So with these both loops, obviously there will be an inside loop for which position we are at. So I is equal to 0, which means that we are at 4 initially, and I is equal to 1, I is equal to 4 and so on. So this inside loop for I means that we are at that index. So now we are at inner loop, and let's assume that I is the index of number, I is the index of the digit we are at for the main string. So for example, we are at 441. So if we are at 441 and I is equal to 2, so I is equal to 4413 and I is equal to 2. So now we got the length of A and we got length of B. So any valid length of A and B are possible. For example, initially this is 4, right? So what if we try to find LA is equal to 4? So what if in the inside loop we have LA is equal to 3 and LB is equal to 3? So this is not valid because we are at index I is equal to 2. So only these can be considered. So if the length of A which we are at inside the loop is more than I, this means that this is not a valid I. This is not a valid A because the digit is up to only I. How can the length be more than I? This means that this is simply padding, because this is not a valid one. This is simply padding by zeros. But what if the length of A is less than or equal to I? So if the length is less than or equal to I, it means that this is valid because we have length 4 and length of A is 3. So we can have these 3. If length is A is 2, these 2, 1, this one. So if the length of A which we are considering is more than the length which we are at, it is obviously wrong. So this is obviously assumption, and this means that it is padding 0. But what if it is less than or equal to I? If it is less than or equal to I, it means that this is valid. And if this is valid, what are the indices of A which we can keep at present index? They are simply 1 to 9 because we cannot add 0, and they are simply 1 to 9. So if this is the case, then we don't have any possibility, so we are using 0 0. If it is less than or equal to I, then we have a choice, and we have choice of keeping any digit from 1 to 9. So we can maintain 4 variables where A start and A end will be storing these both. If it is more than I, 0 0. If it is less than or equal to I, then 1 to 9, and similarly for B. So now what we got? So now we got the length of A and length of B, and also at a given digit we got what is the digit in A and what is the digit in B also. So are we missing anything? Because we will use 2 loops for the length of A and length of B, and we use other loop, and then for every digit we have the digit which we are using presently, and we have digit B also which we are using presently. So we got the both numbers, so we can check whether this is a valid way or not, because in this way we are surely ensuring that any digit is not 0, because we are using only 1 to 9. In this way it is 0, but it is not the number 0, it is simply padding, so we will not consider that. So in this way we are making sure that there is no 0. So now we got the answer. No, because for example, let's say we have 4 digit, and let's assume that we got 1 to 9 for both. For example, if we are at 8 for A and if we are at 7 for 3 for B, if this is the case, then sum is equal to 13, but this is 4, so this is not matching. So how to make sure that the pair which you are selecting follows the present number? So with that, are we missing anything? So till now, when we are at index I, we are only thinking about index I. But what about the digits we stored? What about the digits for A and B we used till now? So there will be a row also. So we have to store those also? No. The only thing which affects the index I from the before integers is only carry. Why? Because let's say we have 3 and 9 for this, and now we are at index I. So when we are at index I, so one carry will be here. So if there is extra sum, the whole number of ways will be changed. So obviously we want a boolean for carry also. So only then we can get whether we are having carry or not. If there is a carry, then the things will change. If there is no carry, then the things will change. And now we have carry also. So for example, if the present digit is 4 and the present digit of A is 3 and the present digit of B is 9 and the carry is 0. So if the sum is 12, is this valid? This is absolutely weird because we only want 4 here, but for A this is ending at 3, for B this is ending at 9. So this is not valid. So before adding the number of ways, we have to check whether the sum of 3 modulo 10 will be 4 or not. Only then this means that this is valid. For example, if this is 2 and 2, so that the sum is 4. So this pair is valid for the present digit, which sum is equal to 4. So before simply adding the ways, we will loop through all possibilities, but it does not mean that for every possibility we'll get the way. So we'll have to filter the number of ways for which the present digit the condition will be satisfied. So and also we got that we have to use carry. So simply at present index we have to find two ways. The first one, what is the number of ways with carry and what is the number of ways without carry. So why we are storing the number of ways with carry? Because when we are storing with carry of index I, this will be useful for I plus 1 because these also will be valid for some scenarios for index I. For example, let's say we have 3 and 9 and the present digit is 6, and for the present we have 2 and 4, 2 and 3. So if this is the way, so if we have a carry, because we have a carry, so we have 1 here, so the total sum will be 6. But if we are not storing 6, like if we are not storing the carry, the total sum is 5. But this is not valid, this is not equal, so we'll simply skip. But if we have a carry, only then we can precisely find whether the total sum is matching or not. So now we'll use other two loops also, one for actual digit of A and other for actual digit for B. And we got the range for which A is used and B is used. So simply A start and end and other B loop. So for every pair A and B, we will check only if the sum modulo 10 is string of A. Why modulo A? Why modulo 10? Because that is the only way to get whether the unit digit is matching or not. If this is not the case, then simply invalid. That is invalid, so don't do anything. So we are using a way for carry also. So simply add another loop for carry is equal to 0 and carry is equal to 1. So now we will try to finalize the solution. So dp of 0 is equal to A. dp of 0 is the number of ways without carry. And initially that is 0 because initially the number of ways is 1. Because by using nothing, we are able to get some 0. So the number of ways is equal to 1 by default. And dp of 1 is the number of ways with carry, which is initially 0. So A start to end other loop, B start to be end other loop, and then for a carry, so for carry is equal to 0 and 1, we have other loop, and we'll consider only sum is equal to sum plus carry whole mod 10 is equal to string type, else is invalid. So let's check the code. So how to update the dp, let's check the code for that. So simply initialize the string and then reverse that. So after this we will get the reverse string, and then total number of is equal to 0. And LA is the length of A. So initially the length of string is M. So we can have M till LA and M till LB. So LA is equal to 1 to M and LB is equal to 1 to M. And now we should maintain dp of 0 is equal to number of ways without carry and dp of 1 with carry. So we can simply maintain dp of 2, dp of array of length 2 of 0 index and 1 index. So dp of 2, which is initially 1 and 0 for every index. Why? Because by default it is 1, because by default we will not select anything, and without carry that will be 1. So 1 0, which will be default for every index. And now we are at index I. So we are at index I. So that also will start from 0 to M. because we have m length, so it will be from 0 to m because this is 0 based indexing. And now we came to a new index, like because when we are reaching now the before iteration completed, or maybe this is 0. So when we are reaching this is a new dp state. So initialize new dp, and based on the previous dp find the present dp. So ndp is equal to 0 0. And now what is the target, what is the present index we are at? It is simply digits of I. So this is the present target we are using for a and b. And now we can find the range of a and b. So if I is less than a, so we discussed that if length of a is more than I, say if I is equal to less, I is less than a, I is less than length of a, only then we can have valid. So a start will be 1 when I is less than la, and a end is equal to 9 if I is less than la. If that is not the case, then both will be invalid, so both are 0. And similarly same for b. And now use a loop for b, use carry for b. And so when we are reaching present index, the dp of previous index is already computed, so we will use that number of ways to find the number of ways for now. So the number of ways with carry or without carry is simply dp of carry. If carry is 0, number of ways without carry. If carry is 1, the number of ways with carry. So if number of ways is 0, so if the number of ways is 0, we are not concerned, because for example the number of ways without carry for the before index is 0. So there is no way that we can use the number of ways for that to get the answer for the present one, because it is 0. So there is no need to consider it. So if it is 0, simply continue. Else start a loop for present digits. So digit A and digit B. So we already have the range, and then find the net sum. So digit A plus digit B plus carry. And if the mod 10 is target, it means that we achieved a present target. So simply ndp of sum of 10 plus is equal to base. So why is this? So we are at ndp, so we have to update ndp so that for the next dp this will be ndp. So if the sum is 10, for example if the sum is 11, after adding the carry the sum is 11. So if the sum is 11, the carry is 1 and the unit digit is 1. So carry is 1, so we have to add ndp of 1, the number of which we have to add in the ndp of 1, because we are achieving carry. So the number of ways which we have now will be added to ndp of carry. So if the sum is target, it means that add the number of ways to carry dp. So if sum by 10 is equal to 1, it means that there is carry. So if there is a carry, then add to ndp of 1. If there is no carry, then add to ndp of 0. In this way we are adding the number of ways to correct carry dp. And then after looping through the carry, update dp and ndp, because after updating the present index we got the number of ways with carry and without carry, and this should be useful for the next index. So simply dp of 0 is equal to ndp of 0, and ndp of 1, like dp of 1 is equal to ndp of 1. And after the whole index, add the dp of 0, because dp of 0 is the number of ways to get the answer without carry, which is exactly we want. Because for example dp of 1, what that does mean? So this means that the number of ways with carry, but we don't want carry, we want the exact number, so we want without carry. So simply return total. In this way we can find the answer. If you have any doubts, comment below. See you in the next video.